Hi everyone, today we'll be talking about our project JoeScript. My name is Emily and my group project members are Casey, Ellie, Marvin, and Jorge. Introduction. So what is JoeScript? JoeScript is a statically typed Python-based language with built-in support for HTML and CSS code generation that makes it easy for Python developers to create static web pages. What makes JoeScript so great? HTML and CSS often is difficult for even experienced coders because it uses unfamiliar and often unintuitive language. JoeScript addresses this issue by abstracting away the complexities of HTML and CSS and allowing users to produce web pages in a more familiar and more Python-like manner.
Moving into the language tutorial for JoeScript. JoeScript is a Python-based language, so it uses familiar Python syntax. It is strongly typed, and it includes static scoping, static typing, strict evaluation order, and support for object-oriented programming, and additionally we've added an HTML library that can be used to create front-end code. So JoeScript supports literals such as int, float, bool, string, and then the operators listed below. We do support lists as well, and the type and length has to be specified at the time that the list is created. As far as control flow, we have if, elif, else blocks, and while loops, just like following Python syntax. And then also we have object-oriented programming supported, where users can define custom classes with member variables and with methods. As far as functions go, we have several built-in functions. So we have casting functions listed here. We also have print and we have len, and then we have support for user-defined functions. And those user-defined functions follow this syntax below. So we use the def keyword, and arguments have their type specified, and then additionally the return type must be specified as well. Looking into the HTML library, we've developed several different HTML types which are implemented as objects in our language. The main object is the page object, and the other objects are different HTML structures that can be added to the page. So there are two helper functions that enable users to use this library in order to create the front-end code. The page.append method allows any of these other HTML structures to be appended to the page, and then the page.create method can be used to generate the actual HTML file. Looking into a more fully fleshed out example, in this case, a user-defined object is created. So we have the student class, and it has member variables, and it has a method, and then a page object is created, and it has its file name specified as well as its title specified. A div is created, and the div has numerous attributes set as well. And finally, the div is appended to the page, and the page is created using the create function, which will generate the actual HTML file.
I'm Marvin, and I'm going to go over the architecture of the JoeScript compiler. Here's an overview of the architecture. Our compiler recognizes the .jo file extension, and when a .jo file is inputted into the compiler returns an executable. To go into more detail, when a user inputs a .jo file into the compiler, it is first concatenated with our lib.jo file in the HTML directory. This file contains declarations of HTML classes like page, div, and link. And once it is concatenated, it will create a combined .jo file, which is fed into the compiler and go through the layers of the compiler and also combined with C code to generate an executable. As mentioned in the previous slides, we have three helper files. lib.jo file in the HTML directory, which includes HTML built-in classes like page, div, link, table, image, input, and form. Helper.c, which contains casting and null checking functions. HTML funcs.c, which includes file generation code. And here are the layers of our compiler. First, our compiler starts with a scanner, which reads a stream of characters and returns tokens. Our parser takes those tokens and returns an AST. Our semantic checker takes the AST and returns an SAST. The code generation then takes the SAST and returns the LLVM code. And finally, the LLVM compiler takes the LLVM code and changes it to assembly code. We also use the C compiler to compile our custom C helper functions into assembly code.
All right, so let's go over the test plan. At first, we would manually create temporary test files to test whatever feature we were working on until we realized we should probably automate this process and save all of our tests. We first created a script used to test everything up to our semantic checker and just made sure an SAST would be correctly generated for all our test files. We eventually created a more complex test script that would run these same tests but compare their output to the expected output in another file. The number of passing tests would be printed out and the results would be written to a log file. In the end, we wrote a total of 67 test cases, all of which passed. So let's go over some of the test cases. The first test shows some basic arithmetic and order of operations. The second one tests our object functionality. Here we declare a class with the name coolClass, which has several instance variables and methods. An object is instantiated, we modify the value of the instance variable A, and then we test method calls by calling a method that accesses the instance variable that was just updated. The last test case shows some of our HTML library functionality and tests it. It creates an upPage object as well as an image object. Some of the image object's instance variables are modified, and then the page's append method is called to append the image to the body of the page. We print out the internal HTML string stored by the page object, and we can see the corresponding HTML.
All right, now let's see a quick demo of how to use JoeScript. So right now I'm in our repo and we can see all the files for the different phases of our compiler. In addition, we have a helper.c file, which helps us with some casting and null checking. And then we also have an HTML folder that has another C file of helper functions, one that can create files, that can append strings together, and then our lib.jo file. And this is a built-in library that can help users declare different HTML objects like divs, links, images, inputs, forms, tables, and pages. So let's see an example of how to create an HTML page. Let's say our group wanted to create a simple page that just showed how much we love Trader Joe's. So the first thing we would do is declare a page. So this will become an HTML output file. And we want to add a title to this page. So we add a new div object that we say welcome to JoeScript, and we want it to have large blue font. And then we'll add this div to our page. Next we want to add a subtitle. We'll give it smaller green text, and then we can add a link straight to the Trader Joe's homepage. We can add an image of the logo. We can create a table that shows all of our members and all of our unis. And then we can create a form object so users can input what their favorite thing about Trader Joe's is. So we'll create one input object that takes in text and another input object for a submit button. And we can add both of these inputs to our form and then add the form to the page. So let's see what happens when we run this file. We can see our Joe file compiled. It printed the HTML code directly into our console, and additionally it created this index.html file. Let's take a look. And here we see that the file that we specified was created. We have a title with large blue text, a subtitle with small green text. Let's take a look at our link. You can see it goes directly to the Trader Joe's page. Here's a table with all of our members and the form that we specified. So obviously this can be extended to make many more different types of pages. So now let's take a look at our test suite. So we have a file and we have 67 different tests. And for each test, like this first one is test arithmetic, we have the code we want to run and the expected output so that we can test a bunch of different features of our code. So if we run make test, we can see all of our different tests are running, and right now all of them are passing. And now we can see 67 out of 67 tests have passed.
And that's it for the demo.
In conclusion, we all found this project to be extremely challenging but very rewarding. We all gained a better understanding of the compilation process as well as memory allocation. In addition, we learned how to design a language as well as how to implement a compiler for the language. Some advice we would have for future students is first, to schedule weekly meetings, second, to start early and make progress every week, third, write test cases early on, and fourth, keep track of group progress. Thank you for listening.